And good morning, everybody. Here are your notes and examples for IXL.com, Algebra 1, section BB.8. And it's going to be solving quadratic equations by factoring. And this is going to be very similar to the last section, BB.7, where we have our factors set equal to 0. And you're going to look to see where each factor could be 0. The only difference is you're going to need to create the factors. So in the last section it was already factored for you, so you might have had maybe one factor multiplied by another factor and it was equal to 0, and you were just looking to see where maybe this factor was 0 and where this factor was 0. If you put in some values for each factor, maybe this was an x minus 3 and this was a x minus 4. How could x minus 3 be 0? X would have to be 3. How could x minus 4 work out to be 0? X would need to be 4. So that's what we were doing in the last section. The only difference for this section is you are going to need to generate these factors. So if you remember back in the AA modules, we did a lot of factoring techniques. So you're going to need to use those factoring techniques to actually create those factors. So let's just jump right into it and go ahead and do a few examples from IXL.com. So here's the first one. We have our quadratic. It's in standard form. Notice it's already set equal to 0 for you. If you ever come across a situation where it's not set equal to 0, you need to make sure you do that first and rearrange your equation so it's set equal to 0. But in this case it already is. So we have x squared minus 5x plus 6 is equal to 0. And factoring techniques, if we don't have a lead coefficient of anything different than 1, so right here we have a lead coefficient of 1 technically, so we can just do factors of the back that sum up to be the middle. So these are those factoring techniques that you studied back in the AA sections when we were doing all of our factoring. So we're going to need something that multiplies to be 6 but adds up to be negative 5. So we're looking for something that multiplies to be 6 but adds to be negative 5. So what are our options for things that multiply to be 6? You could have 1 and 6, or you could have 2 and 3. So which combination is going to get us the positive 6 but the negative 5? So if you do negative on these two, negative 2 times negative 3 is still going to be positive 6, since a negative times a negative is positive. And if you add them, you get negative 5. So it looks like that is our combination. So it's going to need to be x minus 2 and x minus 3. Remember, when factoring, you can always check it by remultiplying. So if you distribute everything back together, x times x is x squared. X times the negative 3 is negative 3x. Negative 2 times the x is negative 2x. And negative 2 times negative 3 is positive 6. And then if you combine your like terms in the middle, then you should get x squared minus 5x plus 6. So it looks like our factors check out. You just want to always double check. Even if you just do that mentally, you want to do a mental check. Make sure those factors make sense. So these look like good factors. So the first factor, x minus 2. So if we look at this first factor, x minus 2, how could x minus 2 be a value of 0? So we make the whole equation work out to be 0, because 0 times anything will be 0. X would have to be 2. So that will be one of our solutions. And what about the second factor? What would x have to be to make that factor 0? X would have to be 3. So if you put a 3 into the equation, you're going to get 0 times something, which will make it a final answer of 0. And if you put a 2 into the equation, you're going to get a final answer of 0. So your two solutions are 2 and 3. Notice the directions are a little bit different than the last module. In the last module, they gave you two separate boxes to type in your answer. For this one, they just give you one box, but they want you to separate your answers with a comma. So when you type this in, you're going to have to type it in as a 2, comma, 3. So 2, comma, 3. Order doesn't matter. You could do 3, comma, 2, 2, comma, 3. Those are your two solutions. So that's your final answer for that one. And let's look at another type. This one you only have two terms. So notice if you look at your two terms, you have a common factor of g. So you have g squared on the first term, plus, and then you just have a g on the second term. So they have a greatest common factor of g. So we can factor a g off of each one. So you're going to take the common g. You're going to pull a g off of this term, and you're going to pull a g off of this term. So a g can be factored off. And what's left behind on that first term, you would need a g, because if you distribute it back in, then that's your g squared. So when you're factoring something off, you're basically just reversing the distribution. So that's going to be a g factored off, plus, if you factored the g off of the 32, then what would be left behind? You would just have a 32. And again, check it by remultiplying. If you distribute the g back in, you should have g squared plus 32, which is what you had originally. And this is all set equal to 0 still. So now we have two factors. One of the factors is just a factor of g. So how could g be 0? Well, g would have to be 0. So one solution, g needs to be 0. And the second factor, g plus 32, what would g need to be to make the set of parentheses work out to be 0? G would have to be negative 32. So negative 32 plus 32 would make 0, so g itself needs to be negative 32 to make that set of parentheses be 0. So your two answers, you have a 0, comma, negative 32. And the next one, very similar. You have a common factor of n, so n comes off. What's left behind? N plus 21 is equal to 0. So what would n have to be? N would have to be 0. How would I make the parentheses 0? N would have to be negative 21. And that would just go into the answer box. Just make sure you separate your numbers with a comma. And again, we can factor off a common factor of n. And what's left behind? N minus 3 equals 0. So what would n have to be? N would have to be 0 to make the whole equation work out to be 0. Or n could be 3, because 3 minus 3 is 0, and that would make the whole equation 0. So there's your two answers for that one. And this one, they want us to factor off an x. And x minus 33 would be left behind, equals 0. So x needs to be 0 to make this factor 0, and x needs to be 33 to make that factor 0. And this one we can factor off a t. And t plus 34 equals 0. So t would have to be 0, or t could be negative 34. This one we can factor off an n. So n plus 21 equals 0. So n could be 0, or n could be negative 21. This one a little bit more complex, but same idea. We can factor off a t. And what's left behind, that's going to be 45t plus 37 equals 0. So what would make this factor of t be 0? Well, t would just have to be 0. This one you might not be able to do in your head. This one we want the 45t plus 37 to be 0. So this one you might need to set up your own little equation to finish solving that. So we need 45t plus 37 to somehow work out to be 0. And now you just have a two-step equation to solve. You want to minus 37. So that would get you 45t equals negative 37. And then to finish getting t by itself, divide by 45. So 45's cancel. T would be negative 37 over 45. So you have one solution, t equals 0, and your second solution. And you want to type both those into the answer box. Just make sure you separate them with a comma. So kind of the same idea, just a little bit more complex of a factor here that you need to solve for 0. You probably can't do that in your head. If you can, great. If not, write down that little equation and solve it out with those two steps. This one back to the more simpler ones. A y can be factored off. And y would have to be 0 for this factor to be 0. This one you can probably do in your head. Y minus 38, how would that be 0? Y would have to be 38. So you end up with 38 minus 38. And here's a more complicated one. This one, you have a trinomial, 3 terms. There is no greatest common factor all the way through that can be factored off. You have a lead coefficient. So if you remember your factoring techniques from the earlier modules, if you want to find factors of this, you want to do factors of the back times the front. So the 15 times the 2 that add up to be the middle. And then we'll have to do factor by grouping. So we need factors of 15 times 2, which is 30, that add up to be the middle, negative 17. And what are some factors of 30? We got 1 and 30, 2 and 15, 3 and 10, 6 and 5. You might already kind of see the answer. The 2 and the 15 is what's going to make the 17. So if they're both negative, a negative times a negative is still going to be positive 30, but when you add them, you get negative 17. So that's going to be your correct combination. So what we're going to say is we have 2s squared. The middle term, the negative 17, is coming from negative 15s and a negative 2s. So we're just splitting this middle term from where it came from. It came from a 15 and a 2, and then you have plus 15 on the end. And once you have 4 terms, you can do factor by grouping. So it looks like we can factor off an s. And if you do that, you're going to have a 2s minus 15 left behind. And on the next one, we're going to need a sign change because our binomials need to match. So we'll factor off a negative 1. And you'll need a 2s minus 15. And that's going to be one factor of 2s minus 15. That was the common factor. And what makes up the other factor? It's going to be these two values that were factored off. So the other factor will be s minus 1. And that is still going to be set equal to 0. So we rewrote our original standard form into its factored form. Now we just want to look and see where each one could be 0. So the s minus 1, that one you can probably do in your head, s minus 1, s would have to be 1 in order for this factor to be 0. How could this factor be 0? You might need to set up a small equation and solve that. So 2s minus 15. How could that be 0? Solve it, use your two-step solving technique. So add 15. That will get you 2s equals 15, and then divide both sides by 2. So s would have to be 15 halves. So that will be one solution, and that needs to go into the answer box, and then your other solution was s minus 1. And just don't forget to separate those with a comma. And that should be it. That should be your notes and examples for this module. Big idea is setting factors equal to 0 and looking to see where each of those factors could be 0, so the whole equation works out to be 0.